Hi everybody, today we're thinking about ratios and introducing the idea of ratios. So if I was to draw a rectangle on the board, something like this, and then split it into 4 even parts, and then shade 3 of them, probably most of you could say that, well, 3/4 of this is shaded. But ratios gives us another way to describe parts of a whole and their features. So, for example, I could say that ratios, like fractions, deal with parts of a whole. But, and this is not where they slightly differ, it assigns equal parts of a whole into groups depending on a feature. So, for example, to take the example that I had before where we shaded those 3 parts, I could say that unshaded is to shaded is equal to 1 is to 3. So one part was shaded and then the other, one part was unshaded and then the other 3 parts were shaded. So this colon here we read as into, is to, and then this one was our unshaded parts, and then this 3 was our shaded parts. And notice that if we add 1 and 3, so 1 plus 3 gives us 4, which is the total number of parts. Okay, and so that's the general idea of ratios. Now the feature in this case, where we did the ratio 1 is to 3, the feature that we were putting them into groups was whether they were shaded or not. And then the equal parts were those rectangles, which we split our whole rectangle up into. Okay. Now, when we dealt with fractions, we saw that there was such a thing called equivalent fractions. So equivalent fractions are something like 2 on 4, or 3 on 6, or 1 on 2 are all describing the same fraction. And in the same way, we can say that a ratio like 3 is to 6 is the same ratio as 2 is to 4, which is the same ratio as 1 is to 2. They're all equivalent ratios. They're describing the same amount being put into separate groups. For example, if I take this diagram that I drew up before of my rectangle, well, and split it into 4 and color, let's color 3 sections. So this one, and this one. Well, under the black, that's the ratio of 1 is to 3. So the unshaded is 1 and there are shaded 3 parts. But if you look carefully, let's say I split each of these rectangles in 2. And so by the green, if I just look at the green, then I've shaded in 6 separate little squares and I've got 2 that are unshaded. So the ratio in green is 2 is to 6. That's equal to 1 is to 3. So how do we work between ratios and get equivalent ratios? Well, an equivalent ratio is achieved if the same number is multiplied or divided by all parts of the ratio. So if we were to look at an example, let's say I had my ratio 1 is to 3, to take what I did before. How could we say that 2 is to 6 is an equivalent ratio? Well, I go 1 times 2 is to 3 times 2, which gives me 2 is to 6. Now, I can also divide by the same number. So if I had the ratio 9 is to 18 is to 3, then I could divide all of those by the common factor of 3. So I get 3 is to 6 is to 1. And very importantly, this is what we call in simple form. So, or simplest form, when no common factors exist between all numbers, in the ratio, it is said to be in simplest form. And that's as much as we need to do today.